So now in the physics and the math chapter 11, we are learning about reasoning about the design and execution of research. The scientific methods are that you have initial steps that are focusing on formulating a hypothesis, and then you go into the intermediate steps where you focus on testing that hypothesis, and the final steps provide results for further testing of the hypothesis. So in the first steps, initial steps, you formulate a hypothesis, then you test that hypothesis, and then you provide results for that. The finer method assesses the value of a research question on the basis of whether or not it is feasible, interesting, novel, ethical, and relevant. Feasible, interesting, novel, ethical, relevant. So it's the value of a research question. Medical ethics focus on four tenets: the beneficence, non maleficence, respect for patient autonomy, and justice. Research ethics, they respect for persons, justice, beneficence, must have equipoise, which is a lack of knowledge about which arm of research study is better for the subject. I think this means that you should not know which study or method is better for the subject. And this goes to research ethics, which is different from medical ethics. Now, for the basic science research, it occurs in the lab. So basic science occurs in the lab, not in human subjects. So it's in vitro, not in vivo. And it is often the best type for demonstrating causality because the researcher has the highest degree of control over the experimental conditions. Variables consist of IV, which is manipulated, and dependent variables that you observe for their change. So dependent variables depend on the independent variable, and you can manipulate the independent variable. The controls are positive control. So which one would it be, on the x-axis or the y-axis? On the x-axis, something is continually increasing. So you cannot manipulate it, or can you? You can actually, because you can you can increase the time, right? Or increase the duration or the speed or whatever. And what depends on it is the y-axis, the changes, the ups and downs, and you observe further change. Controls are positive controls, ensuring that a change in the dependent variable occurs when expected, and negative controls, ensuring that no change in the dependent variable occurs when none is expected. So positive controls, making sure that the change in the dependent variable occurs when expected, and negative controls, no change when none is expected. Accuracy or validity is different than precision or reliability. So accuracy is the quality of approximating the true value, and precision is the quality of being consistent in approximations. So you can be precise but not on the bullseye, in the middle of the dart. For example, board, but on the surrounding, you can be precise. In order to be accurate, you need to hit the bullseye. Now, you can also increase your precision with accuracy. So, accuracy is the same as validity, and reliability is how consistent you are. So, true value, validity, and this one is consistency with validation. Sorry, with consistency comes with precision and reliability. Now, populations, for them, your population data is called parameters. For samples, which are a subset of a population, you estimate the sample data are called statistics. The internal validity is if the outcome of the research is that the dependent variable has been affected as a result of manipulating the independent variable. So if the dV has been affected as you have manipulated the IV, then you have internal validity. Any confounding variables have been controlled for, so you have no biases in internal validity. Now, external validity is referring to the ability of a study to be generalized to the population that it describes. So you can replicate your study when your external validity is high. You have within subject design, which controls for individual variations in a measurement by comparing the scores of a subject in one condition to the scores of the same subject in other conditions. So the subject serves as its own control. So you use the same subject in two different conditions and you control for the variations in the measurement by comparing the scores of the subject in one condition and then the other. This is within subject design. Statistical significance refers to the low likelihood of the experimental findings being due to chance. This is where the confidence interval comes into play. The 95% commonly used confidence interval. So this refers to the low likelihood of the experimental findings being due to chance. Clinical significance refers to the usefulness. So we have statistical and clinical significance, two different things. Statistical is low likelihood. For clinical refers to the usefulness or importance of experimental findings to patient care or patient outcomes. The name implies that how useful it is in patient outcomes. And then we have human subject research, where human subjects research is subject to ethical constraints that are generally absent in basic science research. Causal conclusions are harder to determine because circumstances are harder to control. Much of human subject research is observational. Cohort studies. By the way, here we have the independent variable that has control over the dependent variable, and then the moderator variable has control on the relationship between independent variable and mediator variable. And mediator variable can also have an effect on dependent variable. Now, for human subject research, as opposed to basic science research, the human subjects research is subject to ethical constraints. So this is where medical ethics and research ethics come into play. These ethical constraints are generally absent in basic science research. Causal conclusions are harder to determine because circumstances are harder to control. So causal conclusions are harder to determine because circumstances are harder to control. Much of human subject research is observational. Cohort studies. They record exposures throughout time and then assess the rate of a certain outcome. So with cohort, you just have a group, you record exposures throughout time, then assess the rate of a certain outcome. Cross-sectional. They assess both exposure and outcome at the same point in time. So for that, you then assess. For this one, both exposure at the same point in time. Case control studies assess outcome status and then assess for exposure history. So it's kind of a retrospective kind of study. Hill's criteria. Hill's criteria used to determine if causality can be supported. Hill's causality, if causality can be supported. The criteria include temporality, necessary for causality, temporality, necessary for causality, strength, dose response, relationships, consistency, plausibility, etc. We can find out exactly how many factors are at play for Hill's criteria. Then we have biases. The selection bias, the sample differs from the population. So for selection bias, the sample differs from population. Detection arises from educated professionals using their knowledge in an inconsistent way by searching for an outcome disproportionately in certain populations. Hawthorne effect. Behavior of subjects is altered simply by knowing that they are being studied. So behavior is altered knowing that they are being studied. Social desirability bias, a type of response bias that is the tendency of survey respondents to answer questions in a manner that will be viewed favorably by others. Viewed favorably. Okay, I can't. Placebo effect. Results are influenced by the fact that the subjects are aware they are or are not in the control group. Confounding variable. An extraneous variable that relates to both the dependent and independent variables. So confounding is extraneous. Is it the mediator or moderator? Mediating the means by which the IV affects the so how does the independent variable control the dependent variable? It is the middleman between the IV and DV. Moderating variable influences the already established relationship between the IV and DV. Moderators affect the strength Moderators affect the strength of the relationship between the two variables. So moderators affect the strength of the relationship between two variables. Okay, we can definitely come back to this chapter for more, but physics chapter 11 is also over. I'll see you in the next video.